Alright guys, we are going to be working on the links once again. I have a new way that I want to approach these. We're going to have an op 0, op 1, and op 2, and I think we're going to improve the process here. So that's what this video is about. We're going to be making a fixture, we're going to be doing some test machining and some 440 threads, 303 stainless, and we're going to see if we can make these links even better. I'm really excited to share this with you. I thought about this while I was on my way back from Chicago on the airplane, and I was like, ooh, this could be a really good way to save some material, save some time, and just make a better process for these links. Because again, this is kind of the key. If we can get these links going, we know we can get the screws, then the clasp is last. So without further ado, let's get into it. Alright, we are going to try making a new fixture and a new approach to making these links. I'm thinking if we can make a simple fixture, if we look at the side here, that has a simple little cutout here for the radius. This is our 3/8 stock there. I'm wondering if, so this is 6 inches long, if we can prep this material by drilling and tapping some holes, either 440 or M3, and then, or 1032, ideally 440 though. So we'll pre-machine this bar, we'll cut this to length, and then we'll just drill, tap, 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 whatever. Then we can put it in this fixture and we can screw it from the back side. And if I turn this on, you can see I'm gonna get like 1 or 2 threads here. That's all I'm gonna need, and I'll get that in between each one of these links. And we can then machine these, and I think this is actually potentially a better way to machine these links for a few reasons. One of them is we'll be able to go around the full perimeter of the part in one shot. So we'll get rid of any transitions from here to here that we were getting by profiling and surfacing this. And then, let's see here, what was the other one? We could chamfer this top edge much easier. The only downside is, obviously, we have to flip this to do an op 2, which I'm kind of okay with in this sense because we'll get that clean face up there versus the way we were machining it before, right? We were ending up with a little tab on the back of this. And we were going to have to do an op 2 of some kind. I don't think there was a hand finishing option here. So the only downside to this is these edges here, we won't be able to add a small 10th radius. The reason why is because in this orientation, how we're doing it normally is we can just surface it. But with this, we obviously can't reach it. I do have an undercutting chamfer tool that we could hit this and these edges with a chamfer. It won't come up to this corner, obviously, you know, up here, but I think we're gonna have to try it. I think we have to try this. The one positive to this, also on top of a few other things, is these edges we can now add a small fillet or a radius or a chamfer, whatever I decide. I put a 10th there, and so in this current orientation, the way we're doing it before, we could not deburr that edge. Now, I would argue that this edge this might be more important than this edge. So again, we're gonna have to try this. We're gonna have to see. There's no reason not to add an edge break because we're gonna have to use a key seat cutter anyways to come in here. So I think we should try. This. I think this. The other huge benefit of this is a 6-inch piece of material, and we get, I think there's there's 9 links here. Before, we were doing like, I want to say it was like 2 1/8 inches long to get 1 link. So that times 9. So that would have been, so we're saving 3 times the amount of material doing it this way. And that's not only a big deal from a cost perspective, but also, you guys saw, I can just cut 6-inch lengths, do kind of an op 0, and just put the whole strip in there, versus dealing with these tiny little sticks, you know, to make one of these and have all this excess waste. So, again, this material is not expensive, but from a process standpoint, I feel like this is a lot nicer. I'm not going to have to bandsaw 9 different little chunks. It's just going to be one section for 9 parts. I think that's a huge efficiency win if we can get this to work. So I got to make sure I have a key seat cutter that'll work for a few of these operations. The only one that I'm going to key seat cut is this here. I think this bottom side one I'm going to just do in the op 2. The only other potential problem here is on the op 2, we're probably just going to do this in a vise. We could also make a fixture down the line that would solve the issue I'm about to mention, which is if we machine all this, the chances of the thickness of all of these links being exactly the same is very slim. And so if we just went and put this in smooth jaws, there's a high likelihood that we're going to be gripping on one or two of them and not the rest. And then obviously that's a problem for op 2 machining. So I think the long-term solution would be making a fixture with individual little clamps for each one, and we just drop it in there. That's pretty straightforward. That way we can have a little bit of play on each one. I think that's the way to go with that, but I think short term we can for sure do op 1s like this, and then to test the op 2 we could even just cut this off and just do 2 at a time just to test the theory. But yeah, that's kind of where I'm at. I really like this idea from the material handling side of things. Yes, it does add an op 0. We have to drill and tap this stock here, but I feel like that's going to make up for it in the long run as far as like bandsawing and wasted material. So that's kind of where my head's at. So I got to keep working on this, and I got to go check if I got a key seat cutter. I got to find maybe just a little piece of aluminum to do this, and I think I also need to check for, I know I got 440 taps. I need 440 screws. That's another thing. So I need to check for screws and a key seat cutter. So I'm going to go do that. Okay, so we're looking for a key seat cutter. These ones have radiuses. This one's ridiculously large. These are the undercutting chamfer tools I was talking about. So we're definitely going to grab one of those. It looks like I have, those are all radius tools. It's funny, you remember all the things that you did for different jobs. This one, we might need that for a chamfering tool, so I'm also going to grab that. We got some lollipops there. This is also a nice chamfering tool. I like that. We're going to need a new chamfering tool. I know the one I've had in my machine literally since 2019, so that thing is shot, so I don't really do precise chamfers with that. Those all have radiuses. It looks like I've got quite a few of those. Is that what I have in the machine? I know I put one in the machine, so we're gonna have to check that because I don't think that's gonna be big enough, unfortunately. So let's go ahead and check. So what I'm looking for is I need a key seat cutter that can reach in there and cut that feature. Obviously we are hitting the shank there, so I gotta check. I don't know if I have one. This might have been a missed opportunity here because and we can still work on the fixture and whatnot. Let's make sure. So I'm gonna look, there was one in the machine, but I'm pretty sure it's the same one that I'm holding. So let me go ahead and check that. So I found this piece of aluminum. I really like this dimensionally. It's a lot thicker, but I'm pretty sure this is cast, just the way it looks cut. So I don't really want to use that. So I found this other piece. I had a few other options, but this was the thickest piece that I had that's roughly 6 inches. It's a little bit over. I'm not even going to bother cleaning it up to length. It's fine. So if this is roughly 6 inches, the idea is to machine that center slot to kind of create a V groove, and then we can put this 6-inch piece of round bar in the center, and then we can screw it in from the back side, put this down in the vise, and do our op 1 work. One thing that I did just think about that actually really gets me excited is we could do a boatload of op 1s if we had a big fixture or a pallet. We could just line these bars up because we really don't need much. We don't need much room between the two, as long as there's enough room for the 3/16 end mill to get between the two. So we could space these every 3/4 of an inch, and we could do a bunch of op 1s in a, on a vise pallet, for example. So that also, I really like that we're not, what do I want to say? Or even just like one of these pallets right here, right? I mean, we could put this back up here, take this off, right? We could do boom, 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 boom. And if we're getting 9 for every 6 inches, if this is a 6x6 pallet, so we could probably get, call it 5 times 9. So we could get, what is that? Almost 2 bracelets worth in one pallet of op 1s. That would be pretty sick. And then obviously we can make 2 of these and have the robot hot swap them. So or even make more of them, right? I have a 30 rack pallet changer here. So I really like that. Again, the alternative would be to make multiples of, this was our little test fixture that we've been using, and put all the little sticks in here. Again, it works, but that is now every bracelet, if there's 25 links, I have to do 25 bandsaw cuts just to get the material. And then for each one of those, that's, what is it? I think it's like over an inch of wasted material. So we're talking like 2 feet of wasted material per bracelet. I'm not trying to be wasteful per se, but because at the end of the day, you got to make the product, but that is starting to get significant as far as the labor required to cut all of those pieces. So I really like this idea of just doing 6-inch strips. We could even do larger if we wanted to, but we're going to start with 6 just because it's a good easy machinist number with the 6-inch vise. So yeah, I gotta check again for the key seat cutter, and then I don't think I have any 440. Oh, I literally just looked over here. I thought I was gonna have to go to Home Depot. Look at that. Let's see if I can not spill this on camera. These are set screws though. Alright, never mind. I got excited. We still gotta go and get just some 440 screws just to test this theory. But what I'm going to do, gonna get the machine set up. I'm going to take this, put this in there, deck both sides of it, make it flat. I don't really think I need to trim up the sides. It's an Op1 fixture, it's fine. Do the at least top face, bottom face, cut this piece down to 6 inches, go to Home Depot, get those 440 screws, and then we can at least start machining and test this theory. I don't know if we'll have the key seat cutter per se, but we can at least make some good progress. So let's go ahead and do that. Okay, we've got this piece of stock loaded up. I'm going to deck it, and I can't help myself. I am going to clean up the sides so we have good reference to probe on. So let's clean up the sides first. We're just going to use a 3/8 inch end mill here. We're just going to manually do this. I'm going to drop this bad boy down. I'm just going to get it eyeballed here, then we'll close the doors. Make sure we're down on the flutes there. So I'm just going to buzz both sides and then face the top here. Okay, we cleaned up both sides. Now we're going to face the top. I'm probably just going to skip to this, honestly. You guys, I know, it's one of those things, right? I don't know how many of you guys have seen machining footage and how many of you guys haven't, and I'm not really showing some of it. And I know that's probably one of the more fun things to show. Alright, let's go ahead and close those doors. Hand jog, let's turn the spindle on. Man, it's dirty. See if you guys can see that. So I'm just going to manually drop it down until I see it make a chip. We should be able to clean this up in one pass as far as width goes. Alright, right there. I'm going to back off. We're going to go down. 4th thou. Man, that seems really slow. Really? That's it? Alright, we're just going to manually do this. Looks like we didn't fully clean up on Y. Alright, just like that. Open that up. The one thing I don't like about dry machining is it creates a lot of like little dust particles of metal There's no way those are good for you. So sometimes I'll turn the coolant on like I'm doing and kind of just wash everything down. And then if I just get this tool out of here, we're just gonna tool change to the probe. Just because I know I'm gonna need that next, but now we can look at this and there's way less particles in the air, at least metal particles. Okay, so that's good enough. That's obviously just going to be the bottom face. Again, we don't really care. We just want a flat surface. I don't really care what it looks like. So that's nice and flat. We got the ends. So now what we're going to do is we're going to flip this over, and then we can probe that in, and we can drill our holes and machine our slot, and we will have a fixture. I might have to slightly deburr these corners here. This here, I'm just going to deburr this. Basically, I'm just knocking off the sharp edges because I know those can cause problems. We technically didn't fully clean up one little piece on the edge, but it shouldn't affect things because we're gonna probe off the center anyways. So I'm just gonna make sure these are all nice and deburred, and we'll flip this, we'll probe it. I gotta make sure I set the right WCS because I am using a lot of them on my machine already. So we'll get this nice. And I think this will be a great test fixture. It's pretty fun how quickly you can actually do little tests like this. And this might significantly change the outcome of how we make these parts. Again, I wish this piece of material was a little bit thicker. I just don't want it warping, but again, it is an op1 fixture. We should be totally fine, but that's just like the things in my head. I'm thinking of variables, things that could make my life a pain later down the road, so I'm trying to eliminate those as best I can now. Now, the downside is we do not have a key seat cutter that will work, so we're gonna have to order that. I thought, it's funny because I just made a McMaster order we've got now some stub length drills for these links, a few more 440 taps just in case, and then I also ordered, I thought I was going to have to go up to 1/2 inch material from 3/8 to make these links as far as getting the height. But if we can make this work where we literally just get a few threads of engagement on this material, if that's all we can get, and if it's enough to hold that down on the fixture, we should be fine. Otherwise, we're going to have to go to a larger size material to have more meat because we're really pushing it here. I have probably like 10th thou clearance, and that's actually another thing I wanted to double check is actually what is this true size. So it is undersized by about 2 thou, so it's 373, which should be totally fine, but it is somewhat tight tolerance. Okay, let's probe this. All right. Let's see, we're gonna go up here. We're gonna go here, here. We'll do this. We're gonna do 57. Man, that is really blown out. We're gonna go down. We do want to probe that. -5 is fine. X, we'll do 7.2. Y, we'll do 2. Z, -0.45. Sure, why not? All right, let's get you in there. Should be good. That's Z. Go over, down. It might be too far down. It might air out here. Yep. Okay, so we got to change that -0.3. So basically what happened was I set too large of a negative Z height for probing. So like right there, it went down and it touched the top of the vice jaws on Y here. So I reduced that. So right there, see, it doesn't go and touch the jaws. So, and then you see that little movement right after where it like goes to true center. I was actually really close, so that's good. So It's just an eyeballing thing. It's just an ego thing. That's all it is. So that's probed in. That is now G57. So let's see here. Now we got to go grab our program real quick. Okay, so I'm going to get this set up. This is just a simple parallel tool path that's going to go in there. I think I did 4/1000 step down. It doesn't need to be that fine, but I'm doing it nice and slow with the 16th inch ball mill. I'm going to set this up. I'm going to slow it way down. It's set to 31-minute cycle time. I might even slow it down even more because I'm going to go plug my camera battery in, and then I'm going to go to Home Depot while this runs. So that's what I love to do. I love these little efficiencies when you can do that. So I'm going to slow this down. I don't want to break a tool. I'm in no hurry. And get that running, go to Home Depot, get the screws, come back, and then we can do the rest. All right, we got this cut, 6 inches. And we got that machining there. So I'm going to go to Home Depot and get some screws for the fixturing. All right, we've got a tiny little channel machined in there. So I think I'm going to hit that with some Scotch-Brite, and then I'm just trying to see if I had my test rod to play with that. Let me grab that. I don't know, guys, this might work. We've got our test groove there, and I'm just putting this in there, and I'm pushing down, and I'm trying to move it left to right, and I don't know, I think with some screws pulling it down, I think that'll be good enough. So I think the next step is we're going to drill those holes, and then we'll set up to drill and tap one of these. Alright, let's drill these holes. We're definitely going to need to speed this up. This was set for steel. All right. There we go. Rock and roll that. So I just manually sped that up. We're at 8,700 RPMs, 4 inches a minute. I could speed that up even more. Again, this was set for steel for the next thing we're going to be doing, which is drilling those rods. And obviously I got to run coolant here. It is aluminum. I could probably get away with it here, but sorry guys, your viewing pleasure versus the cost of the tool here, I think I'm going to save the tool. So we'll drill these. This is a 114 drill. That's going to give us a clearance for the 440 screws that we got from Home Depot. These screws from Home Depot are not ideal because they are a Phillips head screw, but we're going to make it work for a test. And so after this, we'll confirm that it's a nice slip fit. We'll take this fixture out. We're going to mark which side of this fixture is the front and the back. Not that it really matters since we probed it, but I like to put it in the same way every time. And then we will test this out after we machine one of those test pieces. So, all right, so that was the drill there. Nice and stubby drill. Put those holes in there. So now we got to just double check that this little screw, perfect, drops right in, got a little bit of wiggle, that's perfectly fine. I think that gives us like 10 thou clearance, that's more than enough. So let's go ahead and take this out and let's drill and tap the steel rod. So one quick little thing that I do sometimes, I wanted to mark which way I put this fixture in. And so what I did was I just took my file and made a little notch there. I could have easily put a Sharpie mark on here, but with the coolant, the Sharpie could rub off. So this is something that's not obviously gonna go away, and for something like this, this is not a long-term fixture. This is just a test, so I don't really care if I do that. So it's just a more permanent way to mark something. Some people would center punch maybe a little dot or something like that, but I just grab my file, make a little mark, and we move on. Okay, so what I'm doing is we have a problem and we need a quick solution to it. So all I got to do is take this little piece of material here, and I've got to face about, honestly, just a few thou off, but I'm going to face 10 thou off, and I'm going to see if you guys can guess why I need to do this. A trick for any Haas people, if you're doing anything manual and you want to use this as a DRO, if you hit Edit Memory Hand Jog, it clears everything out. So now you have a clean slate in your distance to go. And so now I can go hand jog down. I want to go down 10 thou, and there we go. And then you can make your cut. Okay, here's the problem. We want to set this up on a parallel, and we want to drill and tap, and in this case we're drilling all the way through. Obviously, maybe not obvious to some people, that would drill straight into that parallel. So what I needed to do was make an aluminum parallel, more or less, but since it's aluminum we can drill into it no problem. Could be a little bit taller, that's fine, but the reason I had to face down it because it was 3/8 of an inch and this was also 3/8 of an inch. So now when I put this in, we're only going to be clamping on the actual stock. We're not going to be clamping on the parallel. So if I close this vise up, we should only be clamping on that rod, and yep, I can still move my parallel out. I'm going to leave it in, but we're not clamping on it because I can wiggle it back and forth a little bit. So that's what we have to do real quick. So let's go ahead and probe this rod in and get machining. Okay, so the first hole we drilled, our Y offset is off, and so it didn't look on center, and you can also see the drill started to walk. So I thought maybe it just walked and we need to machine a flat. So I machined a flat, and it's still not on center. So I gotta reset my Y. What I'm gonna do is I have another piece of material in here and I'm gonna probe that. The way I did it before was I probed this vice jaw and then I split the difference manually. So let's try just probing this, sticking out, and see if that gives us a better result. We shouldn't have to mill a flat with how stubby of a drill that is, but you can see that is not centered on the flat, so clearly our offset is off. Alright, we got it centered and drilling. We just drilled the first hole. I just checked it. It looks much better, so we're going to drill the remaining 8 holes, 9 holes total, and we're going to come in here. I'm going to manually add a little chamfer with my deburring tool, and then we're going to tap those down a 1/4 inch minus probably 1/8 of an inch of the first part of the tap that doesn't have much threads. So we'll get about 1/8 of an inch of threads, and that should be more than enough because we're only going to get a few threads out of this. So this will be the moment of truth here once this is done. So let's go ahead and finish this and we will test it out. So we're tapping those 440s right now. Nice and slow again. I'm in prototyping mindset. I want to make this work. So we're at 100 RPMs, 2.5 inches per minute. Easy does it. We'll get those and then we can test this. One thing I did add a little bit of an edge break with my deburring tool, but then I realized I can't add much because that's eating away at those initial threads that I need to grab onto. So again, we're really pushing it here on how much thread engagement we're gonna be able to get. That's why we went with 440, because it's a small screw and we can hopefully get at least a few revolutions and catch a full thread there. So that's kind of the reasoning behind this. So we will know here very shortly, and we can go from there. Okay, you can see we've got threads. Don't get confused, this is the vice straw, this is the actual part here. So let's go ahead and test that out. All right, here is the moment of truth. We have our Op0 stock, if you will, drilled all the way through, tapped about halfway through. We have our fixture here. So now, in theory, we should be able to line this up and thread a screw through there. So let's see if I can do that. So these screws are barely long enough. They're 1/2 inch long. My fixture's 480. That gives us 20 thou. But hey, that's one screw and we're definitely making contact. I really need a little flathead or something. So let's do the first and the last one. I'm literally using my fingernail to screw that in. So that's 2. I mean, that's already held on there. It's definitely wiggling because it's not tight. Let's do one in the center. And then I'm going to grab a proper tool here. Okay, we stripped one, but the other 2, I feel like I could tighten them more, but I think I would strip that as well. But this is definitely on there, I feel like. I feel like I should be wearing these. I mean, it's on there, but part of me wants to try to... I'm going to grab another screw. Now, these are Home Depot quality screws. I'm going to try another screw in a different position here, and I'm going to like actually try to tighten it fully and see if it strips. Yeah. So that just completely... Yeah, it completely just destroyed. I mean, we're talking literally the first little bit of thread. So okay, let's take this off. Let's take this off. I'm just inspecting the 2 screws that didn't strip, and let's see what our part actually looks like. If our threads are damaged or if it was simply the screws. I think it's simply the screws because there's not enough engagement. Let's just try. Yeah, these screws were really wobbly too. It makes me want to test maybe one of those McMaster set screws. So we have a 440 set screw from McMaster. Still surprisingly wobbly. I checked the pre-tap diameter, it was still 0.089, but there's a lot of wobble. Obviously that's exaggerated by this Allen key, but so this might be the thumbnail right here. Refocus. All right, I'm going to go eat lunch and I'm going to ponder this. All right, we have a few issues. Of course, this is proving to be a little more difficult than I had realized. So the current problem that we have is obviously the 440 screws do not have enough thread engagement. If we look at a side profile view and we turn on our stock and we turn on our screw, really this screw is something like, it's a little bit higher up than that, something like that. And then if we turn on our links like that, so this is our link inside of our stock, and then that's the screw. So we clearly just don't have enough thread engagements because these first few threads aren't complete anyways. So we really need to be like down here, but we don't have that. We don't have that room simply because, again, you can see that is the link. We are all the way up on the top there. There's just no more material. And one thought I had was, well, why not make the screws sacrificial? But there's no real way around that. But the real problem, if I go to, where is it? So the other option is we could go to a larger stock size, which is this larger circle. That's what 1/2 inch looks like. And then obviously we can, let's see if I undo some of this, have a link. Let's see, where's my good link here? I had one that, yeah, so this link, and if we do that and this. So, okay, there's kind of a lot going on here. This would be 1/2 inch stock. This would be the new link, and you could see this distance here gives us way more room to have thread engagement for our screw down here. So we could have even more than that because we could go up to the bottom of that. So that would work, 100% that would work. Okay, put a pin in that. The other thought was, why not use like 1032s and drill 3 holes in the top like this and do the same thing, screw from below, and now we just have, you know, we have less links. We'd have a little chunk in the center and 2 chunks on the side that we wouldn't machine. Yeah, maybe that might work, but this is the real problem that I'm running into. So that's what I thought of. I was like, what if we use a larger screw and we reduce the amount of links we can make in a 6-inch strip? We add a center support instead of every spacing there's a screw. That's how we had it with the 440s. And again, these screws have to be kind of out of the way. They can't be near the part. And so I was like, what if we did these 3? This is where the real problem comes in. I'm gonna need at least minimum 1/2 inch seat key cutter, which is this guy right here, to cut this feature here. And as you can see, that is interfering with this link here. So now all of a sudden, I really have to space these links apart. I have to space them a 1/2 inch from here to, from there to, you know, well, let's go over here. To cut this, I have to space it out a 1/2 inch from there to there. And all of a sudden, you can't make that many of them. Because this keyed seat cutter needs room to come in there and cut that feature. So it's making me rethink all of this. I obviously, if I show you guys this, let's just do this. This is our current setup, right? This is what we were working on. If we, so here's our part. I mean, the 3/8 stock is the perfect size to make it like this, in this orientation, in any way. The 1/2 inch is just, it just seems ridiculously large to make this. There's just so much material that would have to come off the sides. I think I did the math. I mean, if this is 1/2 inch wide and this is 150 wide, So that's, what is that, 350 divided by 2? So 175 thou off both sides. You can see, just to get down to that width, that just seems like such a waste. And again, this material's cheap. I mean, 6 inch, or 1 foot of 1/2 inch is $9, which is what I'm holding. 1 foot of this material, 1/2 inch, is $9. 1 foot of 3/8 is like $4.55. So it's about half the price. So I'd really like to be able to use it if I can. Obviously, if I can't, I can't. And so what I've been thinking is, I have a lot of thoughts. What is the best way to make these parts, right? So let's go back up to Fusion. So another thought, and this kind of goes back to the original fixture design, was originally we had a stick of material like this, and we were orientating the part something like this, right? And that way we can use our 5-axis, we can hit all the sides of this part. And then we had the problem of we're going to have a tab of some kind there. The other issue with this is, again, we'd have to pre-cut all these different little lengths. And then we had the radius not blending with the surface and a few other things that I wasn't a big fan of. So we really want to try to change the orientation of this part. Now, what is modeled here is 1/2 inch. And again, it's a lot of waste. I mean, you can see how much has to come off on both sides there. But a thought I had was, what if we machine these in stacks? Something like this. I mean, we could do, what does this look like if we space this out? So that is 10 parts, and this isn't even 6 inches. This is 4 inches. So if we look at this, all these parts in this rod, what if we machined one like this? We slitting sawed it, and then we have this part, and all we have to do is clean up this backside here and cut this feature, which is what we would do in this scenario anyways. And then we move down our Z height and we make another one. Then we move down our Z height and we make another one. And we just keep going. That way there's no bandsawing of material. That's the big thing here. We still get the orientation we want. The only downside is we are now going to this 1/2 inch material, which I'm not a big fan of, but I don't think it's that big of a deal. Again, the price difference isn't crazy. I mean, it goes from, what is that actually? I mean, that goes from, I don't know. I don't even need to calculate that. So this is the other option. This is what I was wondering if this would be a good route. We could make a fixture that holds multiple bars vertically, and then and this would also give us plenty of room to come in here with a key seat cutter. The problem is I don't want to be making one stick at a time. So I'd probably want to make a fixture that had, I don't know, as many as I could, and we could have, let's just do this real quick. We could have, let's just play around here. Let's just play around while I talk. We could do, something like that, and then we could do, let's just pretend here, let's get rid of that one, let's rotate that. This is going to be really rough, so do not ignore the lack of symmetry here. But we could basically make a fixture and then something like this. If these were flipped around, basically these key seat slots are all facing out, so they all have plenty of room to be machined, and then we can machine everything else, machine it down, machine the next one, machine it down, etc., etc. You know, so we could hold, like, I don't know, I mean, you could hold an array of bars as long as we can keep the rigidity. That's the thing, is if we can somehow make a fixture that chokes up on the bar, and then when we go to drop it, we can maybe slide the whole fixture down, or a plate down that gives it rigidity, and you could just keep doing that until you're down to your last little stub there. That would also, it kind of goes back to the original fixture idea that we had, that I have with the set screw and like the little V's, is we could do something like that. And the benefit of that is, yes, we go from smaller material to larger material, but in this configuration, we are having to do an op 0. Now, I have kind of a thing with op 0s. Everyone's like, oh, it doesn't really count, it's like an op 0. I'm like, no, it's like, that is a setup, that is a time you're touching the stock. If I can eliminate that, I'm going to eliminate that. So in this scenario, if we can figure out a way to clamp these, if it's a collet of some kind on the bottom, and then a support, like I said, that keeps sliding down, that we don't have to touch this material. We literally cut it to 6-inch lengths and we just keep machining them down. There's no op 0. So something like that might be pretty nice. So I'm not gonna lie, this is kind of kicking my butt right now. I didn't think this would be as difficult as it's turned out to be. This 1/2-inch material, again, it's pretty chunky. I mean, no joke. This is a nice little piece of steel right here compared to this little guy. I like the concept of this. I think, if anything, what this kind of told me or showed me was changing the orientation of the part. You know, going from something like machining this vertically to literally just rotating it down. I think that is a huge deal to kind of expand my mind as far as, okay, we can make this part a different way. Again, I think it'd be interesting to get a key seat cutter to machine this slot as I drop that. Take this, put it in a collet block, choke up on it, machine the part 3-axis, and just go from there and just see what the part looks like. See if those radius blends actually make a difference, and go from there. I think that would be the next video here, is going to be trying that. I'm also thinking out loud, if these parts, I'm thinking, how could we get away from using the key seat cutter? If we had these on a pallet in the TRT, we could treat it 3-axis, machine everything I just mentioned except for the key seat cutter. We could then tip it over, slot that slot, right? I'm just thinking, because it would be like this, 3-axis, and then yeah, we could turn it, machine that, could even add maybe that little radius in there. We might be able to get away without the key seat cutter. That's what I'm just thinking. I have nothing against it. They are expensive and it sucks when they break. Anyways, that's where I'm at. I gotta end this video because this video is gonna be really long, but I hope you guys are enjoying this. Thank you so much. Make sure you guys follow the Instagram, and we're gonna keep working on this. So thank you guys so much. Peace out.